Alright, so in this problem it says we're looking at votes for independent candidates. And it says that a politician claims that 50% of voters in Pennsylvania have voted for an independent candidate in past elections. Okay, so the politician claims alright, and so in this case we surveyed 20 randomly selected people. 20 people. And it says that 12 of them have reported voting for an independent candidate. And it says it says the null hypothesis is that the overall proportion of voters in Pennsylvania have voted for an independent candidate is 50%. Okay, so our null hypothesis is that P, the proportion who have voted for independent candidates, is 0.50. So P is the proportion who have voted for independent candidates. Alright, so our alternative will probably be that it doesn't equal that, but we're not so worried about what the alternative hypothesis is right now. It just says, what is the test statistic, okay? So our test statistic is really just what we observed minus what we proposed in our null hypothesis divided by the standard error. Okay, so what did we observe? Our observation is that 12 out of 20 people have voted for an independent candidate. So what we observe is P hat is equal to 0.60. So our test statistic is going to be equal to 0.60 minus our null hypothesis says that we're expecting 0.50, and we're going to divide by our standard error. So our standard error is equal to the square root of P hat times 1 minus P, not P hat, P from our null hypothesis times 1 minus P from our null hypothesis divided by N. So in this case, our standard error is 0.5. 1 minus 0.5 is also 0.5. Divided by our N, we have a survey of 20 people. So this comes out to be 0.112. Okay, so I'm going to divide by 0.112. That's my standard error. So this gives me 0.89. So my test statistic is Z is equal to 0.89.